While the world remained fixated on the tug-of-war between BYD and Tesla, who could deliver more range, who would build the most affordable EV, another automotive giant was quietly working in the background on a breakthrough that could upend the entire industry. Yes, we're talking about General Motors. Away from the spotlight, GM was developing a revolutionary technology, one that doesn't rely on electricity or traditional fuels. Instead, it's a zero-emission engine that challenges everything we know about how cars operate. This isn't just a new invention, it's a complete paradigm shift. Experts believe this could render both EVs and internal combustion engines obsolete, redefining what a vehicle is. If this innovation scales successfully, it could become GM's biggest game-changer, ushering in a new era not just in automobiles but across the entire energy sector. Could a third contender now win the race long dominated by Tesla and BYD? Before we explore this silent revolution, make sure to subscribe so you don't miss the latest updates in game-changing technology. For years, GM has been on the hunt for a solution that goes beyond electric vehicles. Something that's eco-friendly, has long range, low cost, and minimal reliance on charging infrastructure. In that quest, they turned to an old but often overlooked idea: compressed air technology. It may sound surprising, but the concept of using air as an energy source isn't new. Back in the late 1800s, cities like Paris used compressed air to power trams and mining equipment. But as gasoline and diesel engines took over, air-powered tech was sidelined. Fast forward to around 2010, when Peugeot made a fresh attempt to revive it. They developed a hybrid system combining compressed air with a traditional combustion engine. It worked, delivering eco-friendly performance without the need for batteries. But the project never made it past testing. GM, however, saw the untapped potential and took the idea seriously. While the world rushed toward electrification, GM quietly began research and development, convinced that compressed air could become a powerful, clean, and scalable alternative. Now they've brought the technology to a whole new level. But how exactly do compressed air vehicles work? If you're imagining something like a battery or fuel engine, think again. The mechanism is totally different. These vehicles neither burn fuel nor rely on heavy batteries. Their power comes from pressurized air. This type of engine, known as a compressed air engine or pneumatic engine, might resemble a traditional one with pistons, cylinders, and valves, but the process inside is unique. Instead of combustion, high-pressure air is released into a chamber, forcefully pushing a piston forward. A spring then pulls it back after the air escapes. This back-and-forth motion drives the wheels. No fuel, no emissions, just air and mechanical motion. What makes this even more interesting is that these engines share a similar architecture with existing internal combustion engines. That means companies like GM can adopt the technology without overhauling their entire manufacturing process, a huge advantage in scaling production quickly and cost-effectively. So what makes this technology stand out from EVs and fuel-powered cars? First, its biggest strength: 100% pollution-free operation. No fuel is burned, no harmful gases are emitted, just pressurized air, freely available in our environment. It doesn't contribute to greenhouse gases and leaves no environmental footprint. Second, cost. Unlike EVs, which depend on rare and expensive minerals like lithium and cobalt, compressed air engines use cheap, abundant materials, making them far more affordable to manufacture. Plus, they don't require complex, heavy-duty structures or high-temperature resistant parts. Lighter materials can be used, making vehicles not only cheaper, but also faster to produce and lighter to drive. Another subtle but significant edge: energy source cleanliness. While EVs themselves are clean, the electricity that charges them often comes from coal or gas. Compressed air vehicles don't rely on the grid, offering a truly clean and independent alternative. And let's not forget operating costs. No fuel, no charging stations, just pressurize air and go. No chemicals burned, no metals consumed, and no toxic emissions. Even better, the air that exits the engine is the same as what entered. No waste whatsoever. It sounds like a dream. But as with all technologies, there are challenges. The biggest hurdle: low energy density. Compared to fuel or batteries, compressed air doesn't pack much power. To compensate, the engine needs to operate at extremely high RPMs, which increases wear and tear. Torque is another issue. These engines struggle to generate the pulling power needed for heavy loads or rough terrain. Then there's lubrication. Without liquid fuel, it's difficult to keep parts lubricated, increasing maintenance requirements. And while air is free, efficiency is not. Prototypes so far have delivered a modest range of about 120 to 140 kilometers. Great for city driving, but not ideal for highways. And let's talk about safety. Early prototypes stored air in steel tanks, heavy, bulky, and potentially dangerous. A collision or rupture could turn your car into a ticking time bomb. Think, driving inside a pressurized container. But this is where GM started turning things around. They swapped out old tanks for next-gen high-pressure air tanks, storing air at much higher pressure, effectively doubling power and improving performance to match that of a gasoline vehicle. While torque still lags behind, it's now sufficient for everyday city driving. Even more impressive, GM turned the vehicle's chassis into an air storage system. Instead of a separate tank, the car's frame itself holds the air, made with lightweight, ultra-strong composite materials, like fiber-reinforced thermoplastics. The result? A lighter, safer and faster vehicle with no explosion risk. GM's strategic approach appears to be working, and we might be nearing the moment when compressed air-powered vehicles become real contenders on the road. So when will we finally see them? It's hard to give a precise timeline, but considering GM's momentum and R&D investments, it's likely this technology could hit production within the next few years. GM isn't just experimenting in labs, they're actively addressing technical roadblocks: torque, range, safety, and efficiency. This isn't a short-term gimmick, it's a long-term strategy. For GM, this isn't just a move towards sustainability, it's a bold business maneuver. With combustion engines on the decline and GM trailing in the EV race, this could be their way to leapfrog the competition and rewrite the rules of the auto industry. If you're wondering whether anyone's tried this before, the answer is yes, but not successfully. Peugeot once introduced a hybrid model, the 2008 Hybrid Air, that combined compressed air with a combustion engine. It promised over 120 miles per gallon, better than any electric vehicle or hybrid at the time. But the project was suddenly shelved. Peugeot claimed it wasn't economically viable, but many questioned whether deeper forces were at play. Consider the case of Stanley Meyer, who in the 1990s claimed to have built a car powered by water. Once he made it public, oil interests allegedly pressured him to label his tech a hoax. He refused. In 1998, during a dinner with potential investors, Meyer ran out of the restaurant shouting, "They poisoned me." Moments later, he collapsed and died. His water-powered engine and all his research mysteriously disappeared. Coincidence? Perhaps. But history is full of such mysteries. When a new technology threatens entrenched powers, the resistance isn't always technical. Sometimes it's political. Sometimes it's economic. Often it's invisible. So GM isn't just launching a new technology, they're entering a high-stakes battle. One between a sustainable future and a profit-driven present. If they're serious, they'll need to tread carefully. The story of Peugeot and Stanley Meyer is a stark reminder that innovation can be dangerous, not because it fails, but because it succeeds. Now let's zoom out and see GM's current position. 2024 was a pivotal year for GM. While Tesla, BYD, and Ford locked horns in the EV race, GM quietly made strong moves. They sold around 2.7 million vehicles in the US, their best performance since 2019, retaining their position as the #1 automaker in America. Globally, GM sold 1.36 million vehicles, marking a 1.4% increase over the previous year. Even with a dip in Europe, strong performance in the US and Asia helped balance the scales. Their US market share sits at 16.5%, a formidable number. On the EV front, GM made major strides. They sold 42,000 electric vehicles in 2024, a 50% increase over 2023. The Chevy Equinox EV became the best-selling electric SUV in the US, with over 28,000 units sold. While Tesla still leads globally in EVs, GM is closing the gap in the US. growing its EV market share from 6% to 9% and establishing itself as the second-largest EV player in America. While Tesla focuses on high-end features like autopilot, GM is aiming at the everyday driver, with affordable, practical, and sustainable EVs. But now, with compressed air engines in the mix, GM is gearing up for something even bigger, a new race, one that might just leave both Tesla and BYD behind.